All right, so to finish these notes for today, we had started talking about positive and negative, and we talked about the fact that the positive part of a graph is when it's above the x-axis, when the y values are positive, and negative is when it's below the x-axis because the y values are negative. Then we talked about even symmetry, which is symmetrical to the y-axis, which means I can fold it at the y-axis, and odd, which is the origin, which means I can kind of split it and then rotate it. And if I rotate it, it's going to land exactly identical on the other side. Now, when we had left off, we had one equation left. So if I go put that in Desmos, I can see my graph here. Now, when I look at this graph, there's a few things that I notice. So if I look and I just kind of draw myself a general sketch here, I can see that I have a graph that looks something similar to this. Now, this is not a function. How do I know it's not a function? Because it doesn't pass the vertical line test. So when I look at it, I can't really tell you what's positive or negative because there's both sections of this graph that are above the x-axis that are the same y's, and then this is below the x-axis. And if I notice, I have a x value here that has a positive section, and I have an x value here that's in the negative sections that are in the same sections, or in line with each other. So we're not going to be able to determine what's positive area and what's negative because I'd basically be stating the same thing. I would say, okay, if I look at the graph, this starts at -2. So you're basically saying from -2 to infinity for positive, but it's also the same thing over here, -2 to infinity. So you can't necessarily state that they're positive and negative because of the not being a function part. However, I would like to look at the symmetry. So if I look at the symmetry, so we know that even means it's going to be a reflection over the y-axis, or a rotation symmetry is odd. And this particular graph is not either. So if I'm looking at the y-axis here, if I were to fold that, I can definitely see it's not symmetrical. And then I can also see with the origin, if I were to try to rotate that, they're not going to rotate exactly the same so that they're identical. So this is actually not either. And the reason it's not either is because it's not a function. Not always is a function going to be odd or even if it's a function, but definitely in this situation, this particular graph is not a function, so it can't be symmetrical to the y-axis, nor can it have a rotational symmetry and be odd. Now, let's look at another graph because one of the things that I wanted to kind of look at is some rotational odd symmetry that doesn't necessarily touch the origin. So right here, I can see that in this particular section that it doesn't necessarily touch the origin. So if I drew a general sketch here, and I'm just going to draw it down here, and I have these two graphs, they don't touch the origin or they don't touch the origin because there are some asymptotes there, but I can determine that if I were to take this piece and rotate it, it would land on top of this other one. So this particular graph would be odd even though it's not necessarily touching the origin. It just rotates around the origin. Okay? So with that, the next thing I want to talk about is rate of change. So when we talk about rate of change, this little symbol right here, the little triangle, means change. So rate of change means the change in your y value over the change in your x value. And if you think back to Math 1, there was a formula that said y2 minus y1 over x2 minus x1. Now, I'm going to look at the original graph here for y equals 4 minus x squared. So that's the graph that we're going to be looking at to do some rate of change. So I did already have that typed into Desmos so we can see it. And it comes out to be this parabola. And I'm going to ask for a rate of change for a couple of different sections. So I'm going to start with finding the rate of change between x equals 2 and x equals 4. Now, how do I do that? Well, I'm going to go look at my graph, and I'm going to go where 2 is, and if I go to the point of 2 on the graph, I can see that it connects at 2, 0. So 2, 0 is my point there, so I know that I'm going to be working with 2, 0, and at 4, if I go to 4, I can see that 4 is connecting down here. So if I grab my cursor and I go to 4, I have 4 and negative 12. So I know in this situation, this is going to be my x1, y1, x2, y2. And then I just set it up. So this is going to be negative 12 minus 0 for y2 minus y1, and then 4 minus 2. So that's going to be negative 12 over 2. So my rate of change is going to be negative 6 for that particular interval. Now, the rate of change is going to completely be different based off of which interval you're looking at. So the next one I'm going to look at is x equals negative 1 and x equals 3. So again, I can go right to my graph, and I'm going to go to negative 1. So on my graph at negative 1, I can move my cursor to negative 1, and I have 3. So at negative 1, we have positive 3. And then we're going to do the same thing at 3. So we're going to go back to my graph, and we're going to go to 3. And at 3, I have 5. Or excuse me, negative 5. Alright, so I'm going to go to 3 and negative 5. And then I'm going to do my rate of change. So this is x1, y1, x2, y2. So this is going to be negative 5 minus 3. And then it's going to be 3 minus negative 1. So the minus is part of the formula, and then 1 is negative. So I have negative 8 over positive 4, which is going to reduce down to negative 2. Now, they don't always reduce to nice integers, so if you wind up getting a fraction, that's okay. So with rate of change, remember rate of change is y2 minus y1 over x2 minus x1. And you can always go to your graph in order to find those values.